Hello everyone, welcome you all once again. Here I am going to discuss you people that is fundamentals of the analysis of algorithm efficiency. So in this I am going to cover the big O notation, big omega notation and big theta notation. Big O notation, a function t of n is said to be in big O of g of n, that is denoted t of n is a subset of big O of g of n if the t of n is bounded above by some constant multiple of g of n for all large n. That is, there exists some positive constant c and some non-negative integer number such that t of n less than or equal to cg of n for all n greater than or equal to num. Then for example, if you consider 100n plus 5 is a subset of big O of n square, we can show that particular thing here in the graph. That is, for t of n is subset of big O of g of n, and this indicates that is big O notation how works. That is about big O notation. The next we have big O omega notation. A function t of n is said to be in big O of g of n, denoted t of n is a subset of big O of g of n if t of n is bounded below by some positive constant multiple of g of n for all large n. Then next, for example, if you consider n cube is a subset of big omega of n square, then we can give the proof like n cube is greater than or equal to n square for all n greater than or equal to 0, and that is we can select c equal to 1 and n not equal to 0. This is how we can draw the graph that doesn't matter whether t of n and cg of n is larger. This is how the omega notation works. This is all about big omega notation. The next we have big theta notation. A function t of n is said to be in theta of g of n, denoted t of n belongs to theta of g of n. Then if t of n is bounded both above and below by some positive constant multiples of g of n for all large n, if there exists some positive constant c1 and c2 and some non-negative integer n naught such that c2 g of n less than or equal to t of n, that is less than or equal to c1 g of n for all n greater than or equal to n naught. With this definition of big theta notation, we can draw the graph that doesn't matter for the value of n naught and c1 of g t of n, c1 g of n, t1 t of n and c2 g of n for n, for input size n for the function t. Then this is about big theta notation. So now let us summarize what we learnt. We discussed big O notation, big omega notation and big theta notation, and definitely, as I said, these three notations will be helping you people a lot for analyzing the algorithms and finding the efficiency of those algorithms of different types. So if you are having any doubts, please do ask your queries, and I am here, Nagaraj SK, signing off with this. Thank you very much.